Okay, so now we're going to talk about another derivative rule. So another rule for us to add to our tool belt, and that is rules for natural logarithms. And it's actually a really nice one. So what we're going to do is we're going to take a function like the natural log of x, and we're going to take the derivative. So d dx of the natural log of x. And this one's really nice because it's simply 1 over x. Okay, so that one's pretty basic. All right, let's take a look at what would happen if this was some kind of a composite function. So if there was some other function other than x inside of the natural log function. Okay, so let's say if f of x is, suppose, a natural log of g of x. So something that looks like that. Okay, so a natural log of g of x. Then we're going to take the derivative f prime of x, and we're going to say, well, it's simply 1 over g of x times g prime of x, which is the derivative of the inside. So if you look at it, you should start making the connection that this is really related to the chain rule. Okay, so what we're going to do is we're going to take a look at a few examples, and they're really not terribly difficult. The simplification might seem difficult, but it's not too much that you'll have to worry about. So let's take a look at this one. We have f of x equals the natural log of 2x minus 3. So to get started, we say f prime of x is 1 over the inside, so 1 over 2x minus 3 times the derivative of the inside. And if you look at the inside, the derivative of 2x minus 3 is just 2. To clean this up just a bit more, all you have to do is multiply 2 times 1, and you get 2 over 2x minus 3. So it looks a lot like this. Okay? All right. So nothing really to it, to these natural logarithm derivatives. Pretty straightforward, pretty easy. Okay, so let's take a look at another example. All right, we've got another function here. And we're going to have f of x equals the natural log of 3x squared plus 2x. Okay, so f prime of x, again, is going to be 1 over 3x squared plus 2x. Okay, so 1 over the inside multiplied by the derivative of the inside. So the derivative of this right here, and it's just a pretty straightforward power rule derivative. So the derivative of 3x squared is 6x, and the derivative of 2x is 2. All right, so when you clean it up just a little bit more, you end up with something that looks like this: 6x plus 2 over 3x squared plus 2x. And that right there is your final answer. Now, yes, there's a lot of 6s, a lot of 2s, 3s, and you can factor out a greatest common factor here. But if you do that, you're not going to have anything that cancels out or anything like that. So this one is acceptable to leave like this. Okay? Now let's take a look at one last example. And this one right here is actually really nice. Okay, so it's really nice because you're dealing again with a square root function. So what I'm going to do first is I'm going to rewrite it. Well, actually, let's forget the rewriting part. Let's just go ahead and just dive in and take the derivative. I thought about it for a second and I changed my mind. It's just 1 over the square root of 2x minus 4, okay, times, all right, now the derivative of the inside. So this part right here, we may consider adjusting. Let's write it like this. Let's suppose u equals 2x minus 4 to the 1/2 power. And I want to find u prime because that's what I'm going to need. All right, I want to find u prime. So that's going to be 1/2 times 2x minus 4 to the negative 1/2, because remember we're subtracting 1, and then we multiply by the derivative of the inside, which is just 2. And the 1/2 and the 2 end up canceling, and you're kind of just left with this right here, which is 2x minus 4 to the negative 1/2. All right, now when you think about this, this is really 1 over 2x minus 4 to the positive 1/2, which is just 1 over the square root of 2x minus 4. So what ends up happening, remember you multiply by the derivative of the inside, which is this guy right here. If this is the derivative of the inside, then you're just going to multiply by 1 over the square root of 2x minus 4. So we kind of did all the work on the side over here. And think about it. What happens when you square a square root? Well, you get rid of the square root. You end up with something that looks like this, 1 over, and excuse me, I was about to write a square root and it's gone. 1 over 2x minus 4. And it looks just like that. Okay, so there is the answer for this problem. And as you can see, we applied the derivative rule for natural logarithmic functions. Nothing terribly difficult. Remember, it's basically if you were to take the derivative of the function, suppose ln of x, right? It's just 1 over x, and then of course you'd multiply by the derivative of the inside, but in this case that's just 1. So sometimes they may say d du of the natural log of u, and they'll say, well, it's 1 over u times u prime. Okay, so this is probably more appropriate here instead of using x. But again, another play on the chain rule. So I hope you understood this concept. Hope you can apply it in whatever it is that you're studying and maybe problems that you're going over. And if you like this video, remember, like and subscribe. Thank you.